Okay. Before we start the presentations, let me just quickly introduce myself. I didn't do that properly this morning. My name is Henrik Nilsson. I work here at WMU as a research associate, and I have been involved a little bit in the development of the Lanovansue exercise, but only a tiny little bit. Gonzalo and Annika has made most of the work there. Annika is currently distributing the updated agendas. I think you have 3 versions now. Hopefully this is the last one. We still have a speaker that comes in this afternoon, and I hope he will come so we don't have to change the agenda again. None of them, they will come now. I will soon introduce them as soon as we have the agenda. Okay. Then I switch to the microphone because we are going to record the presentations from now on. And before lunch we will have 2 presentations. The first one done by Mr. Hermanni Backer, coming from the HELCOM, working as a professional secretary in the MSP and response groups. And Hermanni will talk about ecosystem approach in MSP in HELCOM. Then I leave the floor to you, Hermanni.
Thank you. So, good day everybody. I have not been on this course before, but I've seen this on the internet in a way, in various emails. So for me it has been quite a nice looking course. I wish I myself could have attended, but unfortunately this has not been the case. So I will give a presentation now about HELCOM and ecosystem approach, mostly ecosystem approach. And then in the afternoon there will be another one, which will more specifically deal then with a case study on MSP that I was also personally involved in, which is this Plum Botnia exercise you might have heard of. So I just this ecosystem approach that I will start off and now kind of is for me is a bit interesting concept, because for me as a marine bureaucrat or administrator, it has been a thing that have so to say following me from the beginning of my career since 2004, and it is something that is still a bit in the air, one could say. It is not so to say settled really yet, and for one that then tries to apply this kind of concept in a new emerging field, which in itself is maybe a bit blurry, like MSP, it must be quite a challenge, I can imagine. So what now I will maybe then describe is a one version of the story. You might have your own. I don't think it's forbidden. And the thing is that I think this is what maybe is the most valuable with this kind of concept, that it kind of helps us to develop new things from what they maybe somebody meant originally is not necessarily what they will be in the future. So a bit I understand that this spatial planning as a field is very much also characterized by this kind of thing. You do a plan, but then the reality is maybe not what you were actually exactly what you intended in the beginning. So as a start, I could do something that I don't usually do, because I am a bureaucrat, as you know, and the bureaucrats tend to take the same PowerPoint slide and they tend to show it always to everybody, the same slides. So, and they do it several years in a row, or at least with some minor adjustments, because that is the only way you survive, because you do not have much time, the luxury of preparing for a week for a talk or this kind. So that is unfortunate fact, and you tend also to then to also state the what the organization is expecting you to state, which is either not very fruitful for academic discussion. So I will take you to the ancient Egypt as a start, of all places. So I studied international law a moment ago. It was 3 years ago. I finished a second master degree on international law, and we just by accident we used to have a professor in international law who was visiting from the Cairo American University to Helsinki, and he kind of was very European. He was actually from Spain, but anyway, it kind of at least for me it was quite exotic breath of air to the cold Helsinki. And there, as you know, there is this Nile River, which kind of is quite important for that region, and it's also the place, as we all know, where the old pharaohs kind of were one of those early civilizations of the world. And there is where at least a French philosopher, Michel Serres, has pointed out is a kind of one of those places where the joint origins of, so to say, science and then law kind of find their roots. So in Egypt, as the river flooded every year, all the agricultural lands actually disappeared every year. So there was a specific group of people working for the pharaohs, who then were tasked to kind of to recreate this spatial order of these agricultural lands. And they were this kind of strange bureaucrats called harpedonoptai in Greek, who were then those who were tasked kind of to measure and allot the different fields to each agricultural farmer and unit. And these were then kind of governmental experts who had this special task of making this order in quantifiable terms. So they would then recreate this divine order, which is then represented also by the pharaoh. And as they were the bureaucrats of the pharaoh, they were kind of then the extended arm of this the gods, so to say. So this is kind of how the law and the science kind of have this kind of mutual co-evolution over thousands of years. And when it comes to the topic of environmental law, which is what actually HELCOM is about, and especially international environmental law, because what we are talking about is an international treaty, so that means an agreement between states on the environment, and particularly the Baltic Sea environment. So there then this science have always then had a very important role. And this role of science has then been to kind of first to define the problem. I think even before this HELCOM existed and before the convention, the Helsinki Conventions of 1972-4 was actually even signed. There was already a established cooperation of 80 years, or at least maybe 100 years from the 18th century, 19th century to kind of cooperate on this issue of marine science in the Baltic Sea. So that was the basis, and that also then very much flavored the whole cooperation of this Baltic Sea Environmental Cooperation, or Baltic Sea Environmental Commission since its beginning in the beginning of 80s. And there the Commission does different sorts of assessments, which are then kind of putting a scientific basis for this work of the Commission, which is then political. You agree on measures, but you kind of first look at what's in the sea, and then you make the measures. And this in itself, you might seem that it's very self-evident, but actually when it comes to this kind of international law things, it's actually quite, it didn't used to be that common. The different parts of the world and the environmental, so to say, subjects were actually then, they were not seen as environment, they were property, a bit like property as any lot of land, and they were then dealt with as the national property. So this issue that has then emerged over this 70s and turned into this ecosystem approach is actually that you use some sort of scientific basis as the starting point, and not a simple power struggle over some limited resource, is what this ecosystem in essence is about. So it is about quantification using scientific tools of the environment and using that as the basis of the law. But in addition to this, one can also see that it is something about how this scientific knowledge is then not only seen as information, but as they have authority in themselves. So in a way they become a bit like, as in the old days, there used to be something called the natural law, where the kind of there was a natural order set by God, or as Aristotle has this idea that there was this existing harmony in the world that you shouldn't disturb. Then this kind of scientific thinking has also this kind of dimension, that you not only think that you have the facts, but also that these facts somehow have a authority, or like a normativity in themselves. So this kind of strand of logic is then what has emerged since the 70s, and then slowly baked into this also the conventions and international agreements, is this idea of normativity of these ecosystems. And you can also see it in many different areas of environmental cooperation structures outside this marine environment. So you can see, for example, this climate change convention that you're likely reading about all the time in the newspapers, and there you have certain limits set by this expert body called the International Panel for Climate Change, and they do not directly steer the work of the climate change negotiations, but they do have a quite important normative role. So they are now speaking about how to define then this harmful climate change into a set of criteria on for example, carbon dioxide emissions. And this is what has happened then in the Baltic Sea. So there is firstly this ministerial declaration that was signed in 2003. It put the basis that this ecosystem approach is an important topic, and then there has been this process since this last 10 years to define that in scientific terms. So now what is then at table is that within this environmental regulatory framework that HELCOM has been working on, there is now a set of indicators with so to say quantifiable targets, both for the status at the sea, and then also when it regards to how many tons of nitrogen and phosphorus and other substances can be released to the sea. So, and this step then is mediated through these ecosystem models. That is also something that has been a very characteristic feature of this ecosystem approach. So you have this belief in and use of ecosystem models as a kind of so to say tools to transform these what you have now and what you are aiming at to some of sort of quantifiable figures. So that is how it works in the so to say environmental regulation field. But for this, to make this a bit more, so to say, illustrative, I have also brought with me a kind of a set of brochures or what they are called, like something you can put on the wall almost. And this is a type of way where you are showing these indicators that I talked about, these quantifiable targets in a more visual way with colors and also as graphs. So you can have a loop, and it tells kind of the story of the Baltic Sea developments when it comes to the environmental issues since the last 100 years, and then where the targets currently are and where we are in regards to these targets. That's one thing. But then in addition to these topics of quantification, and then you have the normativity of this ecosystem approach, then one could also see that there is then this element of process. So there is a kind of a willingness to think that this ecosystem, normative ecosystem, so to say, the belief that there is a quantifiable target for a good environment, and then that this target should, so to say, have a normative status, so that you should not only, it shouldn't be only completely, it shouldn't be something that you should do in the preferable pace, but it has some sort of, carries some sort of, you should be somehow guilty if you do not do that thing, or you're somehow a bit criminal if you do not follow this ecosystem laws set by this ecosystem approach. But in addition, there one can see that this could also then have some sort of impact on the process of different activities, like then this marine or maritime spatial planning. So one has then been working in a way to translate this ecosystem concept into this marine spatial planning field within now this also within the Baltic Sea Cooperation and within HELCOM, and how this should interrelate, because of course if maritime spatial planning is then a way to combine different aims and objectives in the region to reach some sort of sustainable future, then of course there should be some sort of link between, for example, these regional measures agreed within HELCOM and then the marine spatial planning, one could imagine. So the solution has been that now this Helsinki Commission, which is one organization, and then WASAB, which is more explicitly spatial planning related organization, so have then joined forces since 2010 and had this joint group where this marine spatial planning has been then discussed and kind of to find ways, among other things, to how this ecosystem approach, what it could mean in the context of maritime spatial planning. And at the moment, the situation is such that there is really no consensus at hand yet on the ecosystem approach in the planning, but there has been now, since the last maybe 1 year, talk about how these different phases of planning will be influenced then by ecosystem approach as a concept. So there's different attempts, and then there is also then to whether that is only a flavoring of the current planning processes, or whether this would then mean something substantially new into the planning process. So one could think this kind of scenario where ecosystem approach is more or less just flavoring the existing planning practices, and then you would somehow use this in the normal, or then you would somehow, it would change the process in some way, that you would have some sort of extra step or some along the way. And it seems that there is reluctance in this extra step thing, naturally. That there is this tendency that there is willingness to see just this as the things as usual, and you would carry out environmentally this sort of ecosystem dimensions through the processes like the SCA, and also then when it comes to you would do it maybe then through this ESPO framework. But then, of course, one can also then imagine or pose the question if there would be a need for or a possibility for another type of thing. You could also then have some sort of link to this scientific work. For example, one could imagine that there could be some sort of assessment step. I don't know what it could mean be then in the before the planning process, which would be something somehow we have to link to in a so to say new way in the end point. So you would have to reflect back on the actual facts collected in the beginning. But this is something that's still in the air, and no so to say conclusions have been really reached on this. So maybe this as a short introduction. I do not know if I have that much more. I can show you still the Baltic Sea, the HELCOM way of doing these limits, just so you can find a better picture of that on my PowerPoint. But so. So the Baltic Sea, as you can see here, and what is then important when it comes to this, there's some of these target setting that I will talk about is just the maybe the catchment area, which is often quite easy to forget because you can see the black area here is where the water drains to the Baltic Sea. So this has like quite importance to the environmental management, so that it is not. For example, whole of only Baltic Sea where it's important areas, but you can see here, for example, large parts of Belarus are actually also draining into the Baltic Sea. No. So here you can see a typical convention, environmental treaty, and the Helsinki Convention aims. So in a way that it just shows how this kind of a treaty text is usually then has quite overall aims. So what then this Helsinki Convention aims to is to eliminate pollution, to promote ecological restoration and preservation of its ecological balance. Then there is another article. There is something about conserving habitats and diversity, protect ecological processes, ensure the sustainable use. And this very much like then to the Climate Change Convention, where there is something about stabilization, greenhouse gas concentrations to level that would prevent dangerous anthropogenic interference. And what then this ecosystem approach, as I mentioned, does is then to take kind of these overall objective type of phrases and then tries to turn them into some sort of quantitative. And in the Baltic Sea, then this process started in 2003, and it has been ongoing ever since. And it works like this: that you have then some sort of reference level. So if, for example, you have measured 100 years some water clarity in the Baltic Sea, then you agree on some sort of acceptable deviation from this reference level, which means that then you have some sort of target which is like good enough, and then you try to do different measures so that your curve kind of reaches below then this target level. And then it's this acceptable deviation has this kind of it's partly of course then result of some political compromises, but the thing is that there is still certain, so to say, real threshold values in nature. That is what makes this kind of environmental processes so specific, that in a way there is like certain points where different things happen. So if you reach a kind of a critical point, then there is suddenly there is a drop to a, so to say, another state. So it is not completely then so you have to find some sort of balance between the, so to say, socioeconomic balancing and then these facts of life. And then you end up then with the different types of values. So in the IPCC, for example, you have then some sort of consensus on this kind of, that this would then be the limit of this harmful climate change. Some other authors have different opinions. And this is just an example from an older example from the 30s, where a similar like limit level was set on these sulfur oxides. And then this kind of good status is then usually then put into some sort of law text. So here is then the Water Framework Directive, some sort of biological quality element, something about in this kind of animals living in the bottom of the water bodies, and then there is giving some quantitative boundary here. What is, when do you fulfill the law and when do you not? And these figures also mean that you can then assess them. So for example, this is how then the nutrient pollution was assessed at this HELCOM framework in 2009, and covering then this period 2001 to 2007, and you can see these red dots are then where these kind of limits were not met. And it kind of shows that quite few, it's only up here in the north when the open bodies were kind of fulfilling these agreed targets. So this means the background level plus this acceptable deviation. And then you can use modeling then to kind of or you use it, and what it also then shows in a way the benefits of this kind of measures. So that, okay, it costs a lot of money to reach these targets, but then, for example, you can show that with this investment you can have 50% less blue-green algal blooms, or 50% more blue-green algal blooms, as an example. And then you can use them also as a kind of a way to find areas where the nature is particularly stressed, so to say, by different activities, and where it is not then that much disturbed by activities. Now this approach uses a bit different. It doesn't use the same figures, but still there is a kind of same logic that you're kind of quantifying the environmental status. And maybe this is the one that then you can more directly use in the planning when it comes to this kind of status information. So you can then maybe have access to different, more or less scientifically agreed maps where the environment is especially valuable or especially threatened, that could then be used in the planning phase. But I maybe think that these procedural elements of this ecosystem approach might in fact be more important. So that was my short talk. I don't know if you have some questions. I can answer quite happily. Yes. Mm.